and I hope you're all having a good time at Container Days 2018. I think it's been a great event, definitely for me up till now. I've really enjoyed it, and I want to welcome you to our talk. We're talking about managing and running multiple Kubernetes clusters in hybrid setups.
So, as a quick introduction for me, my name is Henrik. I work at Loodse. I'm the team lead of the development team. We're mostly working on cloud-native software, and we're pretty focused on writing Kubernetes operators. And one of the operators we mostly focus is the one we're going to present right now.
Okay, my name is Simon Pierce. I work for a company based in the heart of Germany, in Berlin, Syseleven. We've been offering managed hosting now for about 10 years. We've got about 4,000 Linux containers that we run at the moment for various customers, a lot of them in the e-commerce or streaming sectors. We also have an OpenStack cloud. We basically were interested in extending our portfolio, and we're looking what could we do with containers. And we looked at various container technologies, and at the end, as a lot of you probably also did, we ended up with Kubernetes. We partnered up with Loodse here from Hamburg, which gave us definitely a large boost in our learning curve. Otherwise, I think we'd still be sitting there trying to figure and get our heads around how Kubernetes works and how you can actually offer it in a managed hosting solution. And we want to talk to you and explain about some of our journey today. So let's kick it off. So basically, what we're going to start off with is the challenge. One of our challenges was running multiple management interface, for multiple clusters. So for us as a service and hosting provider, it's extremely important to be able to see what the customers are running, which versions of Kubernetes are they running, being able to have a good lifecycle management, and be able to manage various clusters for customers. So we might be talking about 50, hundreds of clusters, so not just running like a single cluster. Also, multi-tenancy in Kubernetes, it was a big issue for us. I mean, we have like namespaces and RBAC now, so lots of things that we can do, but is that really a separation between different customers? I don't think it really is, so we needed a lot more than that. So that was also a big challenge for us, and something that we had to get our heads around, how are we going to do this? We wanted to run the master components as a managed service, similar to other cloud service providers like Google. You can't, for instance, see the etcd. They take over the management, which is probably quite good for a lot of people that they actually manage that for you, because it can be tedious, and it's like something that if it breaks, then yeah, Kubernetes cluster is not going to work. So we wanted to make sure that we could take over the management for the API, for the cloud controller, for etcd, and all those other things, because most of the developers here don't really want anything to do with those sort of things. They just want to run workload on Kubernetes. An administration interface. We wanted a self-service portal that people could work with. People could log on to a portal. They could create clusters, delete clusters, check their health status, maybe add additional components at a later date as well. And also for us to basically have a good overview. And we also wanted to have something where we could upgrade multiple clusters, ideally at once. So you'd have like an interface for us admins where we could like log on and we could update maybe 10 or 15 clusters at once we were like happy that the new version worked, and we wanted to run that version. And we could also allow people to upgrade themselves as well if they wanted to. And we also needed to access the K8s master through separate ports, which also allowed us to do firewall things and maybe put a bit of security in front of it. When we first started off, we had all of the customers running through one port, through one service port or TCP port. And the problem there was we were able to distinguish by SNI headers the different clusters and where the request belonged to, but we always needed to adapt Kubernetes to be able to do that. So this way, it's a lot more easier. And we wanted to give our customers a choice of add-ons. It could be something like a CNI. Do you want to run Flannel or Canel, or maybe at a later date, Calico? So you could add things like network security. And we're also thinking, it's not finished yet, but we're also thinking of adding things like ingress controllers if you want to, or allowing people to just click and add an ingress controller maybe as a daemon set to their cluster. Oh, sorry. and we wanted to run the K8s master as a container, which then again allows us to do rolling upgrades of the API server. So basically, once the customer clicks on update my cluster in the Kubernetes backend, you see the new API server gets spawned and the old one gets terminated once the new one is there. So basically, you don't have any disruption of your service if other people are using it at the same time. And that also allows us to have a single service endpoint for multiple clusters. So basically, we have a load balancer, which is in front of our multi-master setup, and then we can distribute the load for the customers between those masters. And we also needed a user role management. For a lot of customers, it's important that they can have some form of role management within their company. We can use RBAC to accomplish this now. Because a lot of people may have distinguished between developers and operators, and you may not want certain people to be able to create namespaces or do other things within the cluster. Installation of Helm charts and add-ons is also a big issue that we needed to accomplish. We're still working on basically installing Helm charts and finding a good way of being able to automate that and being able to give maybe the people a bit of our best practices of things that we found out that work well or that maybe people shouldn't do. And most of the existing tools now focus on single clusters and don't focus on running multiple clusters in different namespaces. So that was also a challenge where Loodse came in. Oh yeah, access to K8s master via separate ports. We already had that one. So. Okay, Henrik.
Yes. So I think we looked actually 2 years ago into the whole issue because we had a lot of customers who were actually really interested in running multiple Kubernetes clusters for the several teams or for even as a managed service like Syseleven now does it. But what all does belong to a managed service? So if you want to have a managed service, you also want to make it easy to each developer to create a new cluster, right? You might also want to create a new cluster in your CI/CD pipeline if you want to do a change, and you do not want to maybe break the development cluster everyone is sharing. You can just create a new cluster and test your stuff in it, and afterwards just throw it away. One of the more tricky parts about Kubernetes clusters is doing an update. Not quite sure if anyone here ever did an update from of kubeadm 1.5 to 1.6. Was quite of a well-known issue that this actually broke a lot of clusters because they forcefully enabled RBAC. So we want to have a sane way of updating clusters, and also in case of a break, we want to do a sane rollback. And if we want to create a new cluster, it's not just we won't deliver it empty, because a normal user expects there's something in it, at least pod networking or kuproxy. And this is something we are currently solving via kind of an add-ons tool. So each new cluster we create, we already deploy some default and opinionated add-ons in it. And one of the interesting parts about having a cluster is to change the number of worker nodes you have. Right now, we solve this by implementing parts of the cluster API, which is an upstream effort from Kubernetes. So there's a working group called Cluster API. And it tries to somehow define APIs to create and manage machines. And this is something we already implemented, and it lets each person to very easily create or remove worker nodes on demand. The next thing is, when already speaking about worker nodes, is autoscaling. This is something which is not done yet. It's something we're discussing upstream. But we are already working on a concept which is the machine deployment. So we have here machine deployment. You define how many machines you want to have in a replicas field and how those machines should look like. And eventually, by using the generic pod autoscaler in Kubernetes, we could eventually utilize it to also scale up worker nodes. When managing a Kubernetes cluster, not quite sure. Who of you is managing a Kubernetes cluster in production? Who does have an automated way of backing up the etcd? Oh, that's a bit disappointing. So one of the first things we implemented was automatic updates for the etcd, because when managing etcd, it might get a bit tricky. It is a bit of a special snowflake in terms of scaling and managing. So when, replacing an etcd node, you need to go into the etcd, remove the etcd member from the cluster, then you can delete the pod, and then add a new one, add the member, and that's a bit tricky. So we added an automated backup and recovery way into the controller we wrote, just to have a sane way of managing a cluster. So the way we basically implemented the whole managing of Kubernetes was we thought about why not running Kubernetes in Kubernetes, right? We could use a deployment for an API server and a stateful set for an etcd. Might sound like a very nice solution, and that's exactly what we did. So for each new cluster, we create a namespace, deploy the API server into it, deploy the control plane, or the rest of the control plane into it, the etcd, and one of the additional things we need to deploy into it is a VPN, which is a VPN server using OpenVPN. And for each new cluster, we expose 2 ports. So one of the ports directly points to the API server, and the other one does point to the OpenVPN server. The reason here is that it's not just Kubernetes is a simple API and everyone just talks to the API. For example, if you use kubectl get pod, right, from your local machine, kubectl will call the API server, it gets the number of pods, and you get the response. When you're using kubectl logs, the kubectl will talk to the API server, and the API server will then talk to the kubelet where the pod is running on and get the logs. And the last part is kubectl proxy. So with kubectl proxy, you can basically proxy your way into the Kubernetes cluster. And for example, if you're running the dashboard in your cluster and you're not exposing it via node port or load balancer, you can access the dashboard via kubectl proxy. And if you use kubectl proxy and try to call the UI, what you will do is you will call the API server, and the API server will check where the dashboard is running on which pod it is running on, and it will then directly call the pod IP. And the issue here in our scenario, when going back, is that the master components are running in a completely separated network. Because we're just managing the mastering components. The worker nodes then are still living at an OpenStack installation at AWS or somewhere else. So we somehow need to bridge into this pod networking, and this is something we do via OpenVPN. Talking about machines, Sebastian already mentioned it in the keynote or in the lightning talk. We are using the cluster API, which exposes a machine set, and a machine deployment. And it's very similar to a pod replica set and deployment. So you have the pod is the single instance, like a machine. Replica set manages multiple machines, and the deployment then manages multiple sets.
Okay, now we come to authorization. That was important for us to support different identity providers. So basically what we can do with something like DEX from CoreOS allows us to use various identity providers. It's possible to use OAuth services, or we basically stuck a bit of glue in there ourselves, and we now are able to authorize against Horizon from OpenStack, which I'll be able to talk about a bit in a minute. Seamless management and cluster logins. What we wanted basically was someone to be able to log into that management dashboard and also be able to use those same credentials, which was working on at the moment, to actually create his clusters. So basically that you've got one seamless login for everything. And something one of my colleagues has just recently worked on and released is actually the authentication against OpenStack. So basically, Dex couldn't speak what we needed, and Kubernetes API server couldn't, so basically we stuck something in between to actually allow that to happen, and now we can actually do proper authentication against Horizon, which is great for us, because the customer only has one credentials. Otherwise, we always had to have people within an organization in GitHub, and they needed another credential set to actually be able to create their machines with an OpenStack, which was a bit too much. RBAC and network policies are also very important in that context. We talk to people a lot about those sort of things at the moment. We hand out a token for all of the clusters, which is basically an admin token which can do everything cluster-wide, but it's very important to be able to break that down into individual components. Also network policies, we offer Cano within all of our customer clusters, so customers can basically very easily implement network policies so that MySQL server may not speak to an Nginx server or vice versa. Multi-provider support, that was also extremely important to us, that we had the same setup for the K8s master throughout various service providers. So we can basically, and I'll come back to that later on during the demo, you can actually see that you'll be able to choose different service providers, but the setup is also the same. What we deploy on most of these providers is a VM. They then get a systemd unit file with kubelet, and the kubelet then starts pulling down the pods that are needed to run the Kubernetes worker node, and then you get connected to the Kubernetes master. So the same team can operate all setups. Because of the self-service dashboard, you can have like teams working on a setup if that's needed, or you can also limit that access to certain members of the team or to an operations team if needed. And also, we have no vendor lock-in here. Most of our things now are running on OpenStack because, of course, we want to utilize our cloud platform. But it's very easily possible to take your stuff and just deploy exactly the same things on OpenStack with exactly the same tooling. So that's not a problem at all. So you have a free choice of public clouds. OK.
Yes. So talking about hybrid setups, someone might think about why actually using the extra route via OpenStack. But if you're thinking about it, if you have a customer who's just running one or two websites and just needs maybe a single node Kubernetes cluster, you won't like sell them a 1 terabyte machine which has 64 cores. I mean, you can, but that's fairly useless if it's a small website. So OpenStack is a fairly nice way to actually partition your whole hardware machines into several smaller ones you can then efficiently use. One of the other ways is that the solution somehow needs to talk to different OpenStack regions, and we need to be able to either just deploy into a single region or spread the workload into different regions. And some customers actually really need bare metal machines, so this somehow needs to be implemented as well. Because in Germany, there are some regulations, so some data might not be stored on some public cloud provider like AWS or Azure, and this data needs to be stored in a secure place and must not be shared with others. So we needed to have an implementation which supports either creating OpenStack clusters or even creating bare metal clusters. And the last point in a hybrid setup, we somehow need to have a generic way of adding new cloud providers. And this is something we already did for a few. So we had already added DigitalOcean, OpenStack, Azure, Hetzner, if someone knows it, and already like kubeadm kind of way where we're just spinning up the masters, and you can just use on your local machine kubeadm join, and then you have your MacBook join the cluster.
OK, then we'll do a bit of a live demo. It's next. See how much time we've got left. Oh, yeah, we've still got a bit of time left. So let's jump into this. OK. So basically, as a lot of you have already heard, we are running our Kubernetes cluster, the majority of our Kubernetes cluster on top of OpenStack, which a lot of people find interesting. I also found it like when I first thought about it, I thought, okay, there's lots of stacks you're putting up on each other, but most of the public cloud providers do more or less exactly the same. So basically, due to virtualization and what Henrik was just saying earlier, it's a good way of being able to separate the different machines. So I already have a few instances here, and now we're going to try and add a Kubernetes cluster and see if we can get a few more instances up here. And I would just log into the Kubernetes dashboard. We've created one especially for this demo, which you can have a look at. As you can see here, you'll be able to log in via Dex with GitHub or Google. In our own cluster that we run in production for our customers, we do the authorization, as I said just a minute ago, against our OpenStack API. So we don't have to, because some business customers, of course, don't want you to send their data to GitHub or anywhere else. Basically, it's a very simple interface. I uploaded my SSH key. That was the first thing I did this morning. And then we basically have a tab for managing clusters, where you've got an overview of your customers, clusters, and you can create a cluster. So we're just going to create a cluster here. And you can pick the Kubernetes version you would like to install. At the moment, we support quite a few versions, from 1.8.0 up to 1.10.3. So we're just going to install the newest version. And just put something on the end of here. And here you can see we can support multiple cloud providers. So we can offer like support for AWS, for Azure, for Hetzner, for OpenStack. And of course, you can take these away if you want to, if people don't want to see these, or you basically wanted to have an isolated bare metal provisioning. We could also put this behind this. So this could be any kind of function. I'm just going to concentrate on OpenStack now and start up a cluster at Syseleven. We have two different regions distributed within Berlin, which you can choose from to make sure that your data is separated, with also two different storage zones. So I'm going to take this region, and basically all you need to do here, this is something we're working on in making this easier for customers, to stop the customer having to enter all this data. That basically when you've authenticated, we pre-fill in a lot more data than we're doing now. You can then choose your flavors. These are basically pre-configured flavors in OpenStack. So it's reading these from my account now. And then we can choose an image. At the moment, I'm going to choose a Ubuntu image to run on. We could also choose different operating systems. We also offer CentOS, and we're going to offer CoreOS as well shortly. And it's also possible to change the container runtime environment. Most people want Docker at the moment, but it would also be possible to use CRY. And you can pick the SSH keys that you've uploaded. And you can, of course, choose the number of workers. We already put a number of minimum 3 workers in there, which we want because to make sure people distribute their workload and they don't create that box that Henrik was talking about, this 64 gigabyte massive box, and put everything on there, because that doesn't make sense at all. Okay, so if I click on next, you basically get an overview page with what's happening and what's going to be done. And I click on create, and you will see the cluster will get created. What happens first? We're now creating a namespace. So I'll quickly open up a show, and I think I can maybe show you some of this, what's actually happening. So if I say kubectl get cluster, then we should see a cluster created, and I'm not sure if it's large enough, but you see we've got a cluster here which has just been created 16 seconds ago. So this is our cluster, and if we look at that namespace, then we should see that stuff is being created in that namespace. So that's G4, and if we ask him for the pods in that namespace, then we should see, oh yeah, it's already been created. So the master components that are needed to run a Kubernetes cluster have been created in that cluster namespace and are under our management. All the nodes are now getting created in the tenant of the customer. So basically, this is my OpenStack tenant. And if we have a look and refresh this, hopefully we should see that nodes are being created.
Small note on this one. I'm pretty sure you select the wrong namespace.
Ah, sorry. Did I?
Yeah, those are live for 3 hours.
Ah, sorry. Yeah, you're right. You're absolutely right. I was quite surprised that was so quick.
Yeah, I was surprised as well.
Here it is. So you see, these are the ones we just created. Sorry, my bad. You can see these have all been created a minute ago. The open VPN server is still being initialized. It's creating certificates and a few other things in the background, but all the other stuff that we need to get our Kubernetes cluster up and running is finished. We have the etcd as a stateful set. Maybe it's easier if I show it this way. The etcd here is a stateful set, the controller manager, the API server, and we've also got a Prometheus so we can see what's happening in the customer clusters and the scheduler to schedule our workload later on. So hopefully the nodes should be starting getting created now. Yeah, we can see them, and there should be some nodes coming up in OpenStack now. Yeah, here they are, 0 minutes. So these nodes are now getting provisioned by our Ubuntu image, which is in OpenStack. And then Kubernetes is going to come and add the kubelet and the token which is needed, or the certificates, to join the master. So we'll let that run, and we'll come back to that later, and we'll continue on with the presentation, and we'll see if we have a ready cluster afterwards, which hopefully should work out. It should take about 5 to 6 minutes. There we are. Okay, next I would like to talk to you a bit about the lessons that we learned during this process. I mean, it took us quite a while to get all this up and running, and there were a few big mistakes that we made. One was, that I talked about earlier, different API server port per cluster because of security regulations and a few other problems that we were having, putting rate limiting maybe on those ports and other things. It wasn't possible if all of the customers need to access one single port. Do not limit etcd memory resources. In some of our first seed clusters, we thought it was a great idea to just run a Docker daemon with etcd on it, and we limited those the memory that those Docker containers could use. Don't do that. It's a really bad idea. It crashed, and we broke all of our seed cluster. Take regular etcd snapshots on a separate storage cluster. It should be something that runs outside of your Kubernetes cluster. Please use an S3, use a different storage region, put it somewhere else, otherwise you will not be able to recover. And as Henrik asked just earlier, how many people do that? We didn't see many hands, so you ought to work on this one. Restrict access to master components. The more access you give people to things like master components they may tamper with, things they can change, things are going to break. You don't want that to happen. Take that away from people. What people want is to be able to deploy workload on Kubernetes. They don't want to fiddle around with API server settings. Most of them don't anyway. Each etcd node needs a persistent volume. That's why we use a stateful set. Every namespace has a stateful set with etcd and a single volume underneath, so it allows us then to recover. In previous versions, we use the etcd operator. This approach is a lot better. Monitor everything. You're always going to have some blind spots, and we found that out later on as well, that our cluster utilization wasn't right, that some of the other things weren't good. Disk I/O, make sure you monitor as much as you possibly can. I mean, Prometheus is a drop-in monitoring tool. It offers a lot out of the box, but there's a lot more endpoints and things you can scrape. And also one lesson that we also learned very hard, build sensible end-to-end tests. Every time we perform an upgrade on our testing or stage cluster, we run a complete customer cluster, we try and spawn a pod in that cluster, we make sure it runs, and when we finish with that, we run, I think it takes about 20 to 25 minutes, we run quite a majority, or the most important, compliance test from Kubernetes. Do this, it's important, and it will save you a lot of hassle. Okay, now last but not least, I would like to talk about the roadmap and some of the things we're planning. Improve the user management process. So basically, take those credentials that the customer has already entered, fill those in, and just give him two drop-down menus for the flavor and for the images. And what I didn't show was there's a few advanced settings, which not very many people need. You could also choose a custom network or custom routers and other things if you have your own subnet and you want to bring it to our cloud. But not many people actually do that. Worker node autoscaling, something that Sebastian from Loodse talked about this morning. Cluster API is definitely the answer to that. Something we're working on, automatically scale worker nodes in OpenStack or other cloud providers, of course, when needed. And maybe even downscale them when people have stopped working if they're not needed anymore. Support for different Linux distributions. You saw that we already offered Ubuntu and CentOS. We also want to offer support for CoreOS. And if there's any customers out there that need anything else, it definitely could be on our roadmap to also integrate those. Could be like Red Hat Enterprise or something else if people really want that. Configuration of external load balancer via ingress rules. There is a project in one of the concepts of Kubernetes called external DNS. It's something we want to contribute to sooner or later. Interesting project. You basically can add your ingress rules, and then you can configure maybe an F5 load balancer, Cloudflare, or other external load balancers you're using. Because don't forget, we're not Google, we're not AWS, we don't have all these nice, fancy layer 7 load balancing services, and a lot of people also would like to use external services instead. So that would allow us then to configure those automatically instead of having to maybe have some form of manual intervention where you have to click up Cloudflare first, which of course would be nice if you could do all of that from Kubernetes. Automate worker node upgrade process. At the moment, you can, as I said earlier, and I can show you in a minute, you can upgrade your master components. We can do that full automatically. But what we don't do at the moment is we don't drain all of your pods from your worker nodes and create new ones. There's also manual intervention needed. I mean, we're talking about like 10 to 15 minutes per cluster, depending on how big it is, but you still need to do something. We also want to work on making that process a lot easier for our customers so they don't have to care about all that lifecycle management. Improve backup experience. At the moment, of course, you can do backups. You can use maybe, if you're using databases which need to be backed, they're on volumes. We make 3 copies of everything, but what if someone deletes the volume? Or what if someone deletes all of the volumes? Heptio, I've got a great project on GitHub called Arc, which allow you to basically back up complete namespaces, inclusive the volumes. Because when you've created volumes with the dynamic volume provisioner, it all works, but you've got like these long UUIDs as a name, and how are you going to find out which volume belonged to which pod if you try and restore that? So Arc takes care of all that. Would also be nice, one of the questions that we get answered a lot, how do you do CI/CD? How many of you have got a working CI/CD pipelines up and running? Quite a few people, but considering how many people are in here, not enough. If you want to run Docker workloads, that is something you're definitely going to need. It would be nice if we could have something with standard. People use Jenkins, Drone, Scaffold. There's like loads of different tools out there. We would like to also make this more of a seamless experience for our customers, that we've got a good way to show them how they can do this. Okay, does anyone have any questions before I go back and see if our cluster got created? And yes?
So you're looking forward to operating more operating systems?
Yeah.
Why does a customer need that? I mean, is that something that they shouldn't be operating as that level of abstraction, right? They should be operating.
Yep, absolutely right.
Do you hand them to customers, or do you say this is the you don't need to worry?
So the question was, why do we really want to support multiple operating systems? Because normally, in normal usage, you just want to have a running Kubernetes cluster, right? You just want to use something which can run containers. The reason is that in a more of an enterprise way, there are companies using Red Hat, and they really want to use Red Hat, especially for the support. So, yeah. Well, we partially manage the nodes, but we're not. At least at Loodse, we're not offering support for the operating system like 24/7. It's more like the customer, or in this case, Syseleven, will do the support. So depending on where the product or the controller runs, you have different environments and different teams which will then operate the whole stack. So this is the most reason.
I suppose it's all about freedom of choice as well. I mean, if someone wants to choose something else, then it wasn't all that much work to implement it for us, and we build these images automatically with Packer and GitLab CI, so it's not really a big issue to us. And we've been asked these questions various times, but you're absolutely right. I believe that as well, that someone should be happy with what they give them, with what we give them, and it should be okay if everyone runs CoreOS, but we heard a lot of people don't want to do that. Yeah, which we obviously do, and we tend to use Ubuntu quite a lot for other sort of setups. We're a very Ubuntu-driven company, but as I said, we find choice is important to a lot of people. Are there any other questions?
So the question was if this was or is available on GitHub. So the controller, which like the cluster operator, which will create the mastering components, that is not. We are currently thinking about open sourcing parts of it, but there hasn't been any decision made so far. But the whole controller, which is responsible for creating worker nodes at AWS or OpenStack, this is completely open source. So the whole cluster API effort in terms of machines, machine set, this is open source and can be found on our GitHub organization, which is Kubernetes, so github.com/Kubernetes, if you're interested.
Okay. So thank you very much for listening. If you have any other questions, then please don't hesitate to approach me or Henrik. We also have a booth just by the entrance of the main area. And I would also like to tell you that if you're interested in winning a Kubernetes workshop, we also have a competition, and you can approach my colleague Florian, who's standing over there. He would be very interested to hand you a leaflet if you're interested. Thank you very much.